number one. Okay, so for number one, how do we find the volume of something with a cross-sectional area? Okay, the question is, what is the integral of, or what is the area of an equilateral triangle? How do we find that? You could find the angle through Pythagorean theorem, or the height, sorry. That is one way of doing it. You can also use a trig function, doesn't matter which way you do it. But yes.
For the equilateral triangle, is the base still the entire flat thing?
Because it says, the part where it says the base of a solid is the region in the first quadrant, then yes.
Okay, and then how would you find the height?
You could do like intercept the Pythagorean theorem, so you know if you draw the height, it's going to cut the base in half, basically. So if you just draw it, so one side will be sine x, one side will be half sine x, then the height will be the Pythagorean theorem of sine squared x minus 1/2 sine squared x, and that all square rooted. Or you could use trig and do it if you want to use trig and do it, because you know it's 60 degrees.
I get that one side is sine x. I just didn't know the other side is. Oh, it's equilateral. Never mind. That's
Yeah,
dumb.
because the equilateral, when you draw the height, it cuts that third side, the bottom in half, to create the
Yeah.
height. So that's one way of doing it, like I said, or you can use the fact that it's a 60-degree angle and use trig if you wanted to. And it doesn't matter which trig function you use. You can either use sine or tangent. Yeah. Do I need to show anything for that, or is that okay?
So it's the integral of one half, um, half of sine x, whatever we figured out, or no, sine x, and then whatever we figure out the height to be.
Yeah, apparently your height should be square root of 3/4 sine.
Okay. Yeah, that's what I
Yeah,
meant.
she changed it. Okay. All right. All right, finally. Yeah, we're doing revolutions. All right. So now, how do we do revolution volume?
Is it the or pi times the integral
So that one is pi times the integral of what, though?
of the radius squared?
Yep. Remember your radius will be your like top minus bottom or right minus left, just like we talked about with the area. We talked when we did the R's last year. They do become a little tricky for you guys in some cases, but this is a pretty basic one since there's only one R. So this is the disk method, if we remember, not the washer method.
So, how do you find the bounds on this one?
So we're in the first quadrant, and the x and y axes. So that's going to give us, this is actually like an ellipse. Yeah, this is an ellipse equation. So you just kind of look and see where it's going to cross the x and y axes, is the way to do it. Because you should know that that graph is going to, x is limited on how far it goes. So x can't go past, 2? And y values are like 8. So it's going to have an x-intercept of 0, or of 2, 0, and a y-intercept of 0, 8. So depending on if we're using x's or if we're using y's, depending on how we're doing it, that will be your bounds. Reminder that if you're revolving around the y-axis, everything needs to be in terms of y's for the disk method. So we have to solve this for y.
So the integral has to be at y points, right?
Yes, your integral will be a y point, so that's why it's important to know that the y-intercept was 0, 8, um, which means your y's will start at 0 and end at 8. So it'll be the integral from 0 to 8. And then we have to do, we have to solve the integral, or solve the equation, sorry, for y, which means we need x equals, in other words, because everything has to be in terms of y's. So you need x equals y, blah, 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 blah. So you'd have to divide by 4, square both sides, and then move it over, and then square root, all that kind of stuff. And then you square it again, because it's when you put it in the integral, it's squared. But you can do that in the calculator. You don't do that by yourself. Do I need to show anything there for anybody?
So I feel like I'm doing the right thing, but I can't get the right answer.
Okay, that's fine. 4 squared, 4 minus x squared.
Are you doing it? Or
Yes,
no?
yes, ma'am.
Okay.
So you get y over 4. So y over 4 is equal to square root of 4 minus x squared. Squared, squared. So I get y squared over 16 is equal to 4 minus x squared. So x squared is equal to 4 minus y squared over 16. Is what I would get. So that would be your y that you need to plug into your integral. So you need the integral from 0 to 8 of 4 minus y squared over 16. And I don't have to square this because it was x squared. That's already squared. dy.
I think I was doing 0 to 2.
So you gotta be careful, it's y numbers, so 0 to 8.
Also, not to be off topic, I have to go by this school today to turn in for something for Chautauqua. What time does the school close? Is it early, or is it 3?
I don't know, to be honest.
Oh, okay.
I would say probably do it roughly around like 12 or so would be a good idea.
Okay, I shouldn't know if they close early or anything.
I don't think they're closed like super early, but it might be like 1 or 2 o'clock. I don't know. They don't tell me these things, to be honest, because
How was moving your stuff?
it's fine.
Is it good?
Yeah, we talked with Laird for a little bit, and then I made them move things and put it all in boxes and put it in the back of my room because I don't have anywhere to store all that stuff at my house, personally.
Gotcha.
Oh, and Tanner shaved. It's very weird. He looks like a little boy. We got all the stuff packed up into boxes in the back of the room. As far as like my stuff, there's still all the science and equipment and stuff like that. I'm sure I'll have to go up there at some point and do something with before they demolish the buildings.
Um, so that
Yes.
integral, is it not being multiplied by pi?
Oh yeah, I need a pie out front. You're right. I just wasn't paying attention.
Okay.
And we don't know when they're actually starting the construction, Bacon. But the word was just pull everything out. I mean, I guess the idea is that yes, they're going to start that, and they'll be moving us into portables for next year, which makes the most sense. Just go ahead and do it. Okay. Ooh, number 3. I probably need a number 3, don't I?
Probably.
Okay. 2 cosine.
Hold on, I'll be right back.
What's the other line? Pi over 4, and line 1 equals 4. Okay. So, what value does cosine have a pi over 4 value? Let's see, cosine has pi over 4 at... Oh, I don't know where cosine has pi over 4. I guess I'll have to solve for that one. Yeah, I will. Okay. So...
When I was doing this one, I wasn't sure if you only, like, if your bounds are from 0 to where they intersect, and then do you not do from the intersection on until the one function goes to 0?
No. That would not be bounded by the y-axis and the two functions at that point. That'd be a whole different thing. So you only are looking, I'm pretty sure at the area I've drawn on the board. If I've drawn it correctly, I'm going to graph it on the graphing calculator here in a
Okay.
second.
Yeah, because that's what the answer worked out to be, just that first area, but I was still trying to add it to the other one because I didn't know when you were supposed to cut it off.
It's so when you draw the graphs, it's a region bounded by the things they give you. So it has to be bounded by all three of the two functions given and the y-axis. If you keep going, the other regions you create would be not bounded by the two functions and the y-axis. So that's why you wouldn't keep going anymore.
Okay.
Let's see, but I'm pretty sure that's the correct graph. Oh, in degrees. Alright, what's cosine 2? Cosine x over 3. Yeah, it looks something like that. Okay, cool. Zoom trick.
Do you have to do the thing where you do like 4 minus or no?
Yep, we will. We'll talk about that in a second. So, bring up the graphing calculator on the screen. There we go. So that's what it looks like. We know we're only doing the right-hand side because it tells me the first quadrant. I know, and what Anna was asking about, I only need that little area that is bounded by all three curves, so y equals 0 being the y-axis, or x equals 0, sorry, and then the 2. So I need that little area that's the little circle, semicircle looking thing, whatever you want to call it. So that's all I need. So the question is, what are my areas, or what are my functions, what are my radii, stuff like that. Since I am rotating around the line y equals 4, we have to ask ourselves, should the integral be x's or should the integral be y's?
X.
So the line y equals 4 is basically the x-axis shifted up, so everything needs to be in terms of x's. So I know it's a dx thing, which is good because they've already solved that stuff for me in those terms. At that point, we just need what are the radii. So I remember last year whenever we did this, you draw 2 lines. So there's one. And there's the other. Oh, black's a little thin.
Calculator still on screen.
Oh, thank you. There you go. So you draw your 2 lines from the axis of rotation to the functions. In this case, we have 2 functions, obviously, so we're going to create a washer. So you have to ask yourself, what is the value of the big one? What is the value of the little one? So that all, obviously the big one's your big R, little one's your little r. So always do, if we remember, so this will be our top, and these will be bottom. So it's always top minus bottom is always the way to go there for as far as to get the length of that. So if you think about there being 3 lines, I guess if you really want to go all the way down to what you're, nah, I wouldn't think about it that way. It's going to complicate things. But anyway, just draw your lines, do top minus bottom, or right minus left if you're doing around y-axes will always work. So top in this case will be 4. Big one always goes first, so 4 minus pi over 4 squared minus, and then the other one will be 4 minus the 2 cosine. X over 3.
Oh wait.
Big
What
R squared
was?
minus little r squared.
Oh, gotcha. Never mind.
Did I answer your question?
Yeah, at first I thought you were just doing the second part. I was confused.
Yeah, so it's always big R squared minus little r squared. And big R in this case, the line is being the red one, we do top minus bottom to find that value, which is the 4 minus pi over 4.
Which is that the washer method?
Yes.
Okay.
The last thing we haven't found yet, what is our bounds? So where does the x's start and where do they stop? Well, the first one's easy. They start at 0. But where do they stop? You do have to find the intersection of the graphs of the 2 functions they gave you. That's not a very obvious point of intersection. So you will use the calculator to find those after you've graphed them, because I highly suggest if they give you a graphing calculator to graph them to see what you're dealing with. And usually they give you a graphing calculator more than just to look at the graph in these types of questions. It's to find like points of intersection and your bounds and stuff like that. And that value ends up being, what is it, 3.397
Yes.
is what the rounded value is.
Did you do the function like equal to, I guess, pi over 4?
So you find that point of intersection right there. So when you have them graphed, you just do find second intersect on the calculate button, remember?
Hold on, it's like lagging. I'm trying to see. Oh, yep, that's where I was talking about.
Yeah.
The right answer for that.
So you do second calculate and then intersect to get that. You said you're not getting the right answer with that, Tanner?
Not.
That's the exact answer they have. I don't know what to tell you. Make sure you're putting the proper numbers of parentheses, especially on the second one. So that way you're not squaring the cosine part, you're squaring the whole thing. Make sure you have a 2 in front of your cosine, etc., etc. The answer should be the 74 number. Any questions? I'm assuming I got that. Okay, I'm going to assume not.
Emitter.
Okay, so moving on to number 4, perimeter. So that's just going to use our arc length formula that we looked at.
So we're back to polar now.
No, this is not polar. This is before polar. We did a arc length, regular arc length, and we did a polar arc length. Or no, I don't think we ever did polar arc length. We should area for polar, if I remember right. Do you remember our arc length formula?
Square root.
There's theta, I think, and I think there's a square in there, maybe.
No
Is it
thetas.
square root? Is it square root?
It's the integral of the square root, but
Okay.
yes.
Square root of
God, I remember
1
it.
plus
It's
dy
super dumb.
dx squared.
Yeah. So it's basically 1 plus the derivative
Wasn't there
squared.
3?
No, there's 2, one for x's and one for y's. That's all.
What is there 3 of? I know there's something.
Uh,
I have it in my notes. It's okay.
I'd have to remember. I'm not quite sure. So yeah, it depends on if you're doing what kind of, if you're doing x's or y's, depending on how the function is given to you. This one's given to us as y, so it'll be the y prime. If it said like x equals, if the function or the equation was determined as x equals, it'd just be dx dy. You do have to be careful. Don't try to solve it for like y or anything like that. But yeah, it's just so. This case is pretty easy. So it'll be integral of square root of 1 plus y prime. For both of them, you have to do two different ones and add them together. And you know it goes from 0 to 4 on both of them. So integral of 0 to 4 of square root of 1 plus, I don't know why they called them both y. They should have called them like y1 and y2 or something. So I'd call the first one y1. So 1 plus y prime, y1 prime squared, and then plus the square root of 1 plus y2 squared. And you should do those two integrals. So pretty easy. Plug into a formula if you know the formula. Questions on that one? Okay. See another volume one. This is a first quadrant bounded by that, and the x and y axis. That's going to be a washer or a disc. Sorry, disc method. Oh, it's cross section perpendicular. Different question. Semicircles. We do have to be careful when you're looking for a semicircle. What do you have to find when dealing with a semicircle to find its area?
It's
Ugh.
1/2.
So it's yes. You have to find the. Remember the fact that it's a 1/2 because it's only a semicircle. You also have to find the radius, which you have to be careful of. The radius is not the entire length of top curve minus bottom curve. So let's see what is it? I forget what the graph of secant looks like. Oh, I don't. It's that thing. So I would definitely graph them. It's not a graphing calculator question. It's a pain in the butt. So I guess it doesn't really matter what the graph looks like. But when you go to graph your secant, the distance from the top, which will be the secant graph, so it actually looks something like that, which you'll see in a second. When you find that distance there, you have to remember that is the diameter of your semicircles. It is not your radius. So when you go to plug in for your radius, you got to cut that value in half.
So would it be pi squared out in front?
No, just be pi over 2 out in front. Because it's 1/2 pi r squared.
I was thinking of pi for volume.
Yeah, no, this is a cross-sectional area, so no pi out front to begin with. So it's just 1/2 pi r squared. Move the pi and 1/2 out front. And your radius in this case will be, because the graph is what, 2 secant x? So it's half of 2 secant x, which is just secant x. So your radius of your semicircles is secant x.
Why on the stream does it say cosine 2 cosine x over 2?
That's left over from the last problem.
Oh, never mind.
Yeah, I didn't pay attention. I just drew the graph.
Can you show this one out?
Yeah. So you have the graph on the. That's the graph of secant x. Where do I stop? Hold on. X equals pi over 4. What's cosine of pi over 4? Square root of 2 over 2. So it's going to be like that. Actually, it's a solid line. Oop. Pi over 4. So your graph looks something along those ranges. Whatever it ends up being, not a big deal. So your, like I said, the distance in here, that is your diameter. So your diameter is equal to 2 secant x, because that's top minus bottom, bottom being 0. So your radius is just secant x. Your formula for your integral of your area is the integral of 1/2 pi r squared dx, because it's an x thing since I'm rotating perpendicular, or cross section is perpendicular to the x-axis. So I'm going to move the pi and the 1/2 out front. And we know our r is equal to secant x. So it's integral of secant squared x dx. Bounds are from 0 to pi over 4. At that point, this is a non-calculator question, so we would have to do it by hand. So the question is, what is the antiderivative of secant squared x?
Is that cotangent? Wait, no.
Isn't it just tangent? Or
Oh, and yeah, that would be tangent.
That is tangent, yes. So that's tangent. So remember, you definitely need to have a list of all your derivatives and antiderivatives so you don't have to guess. And they expect you to do so. So pi over 2 of tangent
When's
x.
the exam again? How many
12th,
weeks?
2.
Got it.
So that's pi over 2 of tan pi over 4 minus tan 0. Here, obviously, they're expecting you to know tangent of pi over 4 and tangent of 0. Since your test will be a calculator, you obviously don't have to do those types of things. But yes, you definitely need to have a list of all the derivatives. Like I said, I'll get you guys a list of informational things that you should have written down and stuff like that. But you should also be making clear, concise notes to yourself and of things you need and stuff like that. Is that good for that question?
Yeah.
Okay, number 6. So this time we're forming isosceles right triangle with the right angle on the y-axis and one leg in the xy plane. Okay, so that's a little, not confusing, but like, okay. And we're doing perpendicular to the y-axis, so when we do our integrals, that's a dy thing. So everything has to be in terms of y's. Do I need to do this one as well?
yeah.
Okay. So I remember the y and y equals 1, I think was one of them. Square root of x, y equals 1, and the y-axis. So we get y equals 1. Square root of x, you have 0, 0. And then, what, 1, 1? So your graph looks something along those lines. In this case, our any kind of length is going to go from there to there because it tells us perpendicular to the y-axis. So when I do my integral, it definitely needs to be dy. At this point, I know my y bounds already are 0 to 1, so that's pretty easy for us. The question is, what is this, or what is the area? So remember, again, it's always integral area, in our case, dy. What is my area formula for an isosceles triangle? When it tells you that one leg is in this place, that means this is the leg of your isosceles triangle. The right angle is on this part, so it's going to look something like that, where this is the leg. So we know that the area is just going to be leg squared, 1/2 leg squared. So we just need whatever the leg is equal in terms of the function. Well, the function in this case being right minus left. So remember, this needs to be solved for y, so we know y squared equals x. So it's integral from 0 to 1, pull the 1/2 out front, of y squared dy. Equals 0 to 1, y to the 4th.
So is the triangle what the thing is making as it's spinning?
It's not spinning, sweetie. It's a cross-sectional area. Remember what we did with the Play-Doh?
Oh. Oh, okay.
Yeah, anytime you spin anything, I don't care what it is, when you spin something, you create a circle every time. That's why with the
Yeah,
disk and
that's
washer method, it's always the pi r squared, because that's always a circle. Cross
okay.
sections have different area formulas.
Okay, that makes sense.
Yeah. Technically, when you do the disk and washer method, you're still doing the integral of the area. It just happens that every time the area is a circle. That's why we can have specific formula of the pi r squared for disk and washer method.
Hmm.
Okay, so number 7 is a revolution, so that's going to need a pi out front. Remember, as soon as you see the revolution part, you're going to need a pi out front, which leads me to believe the answer has to be C or D when I'm looking at that, because I don't think the pi's are going to just go away. And nope, they don't. Okay. So this is we only have one function, the vertical line. So that's going to be we're revolving around the x-axis. Excuse me. So that's a dx. So everything's set up pretty easily for us. The x's are going to start at 0, end at 1. And it's just x to the 4th. So it's integral of pi integral 0, 1 of x to the 8th. Because if you square x to the 4th, you get x to the 8th dx. That one should have been hopefully pretty straightforward. Questions on number 7? Okay. Number 8 appears to be pretty much the same thing, except for you will need to solve, since we're going on the y-axis, you definitely have to solve that for x equals. So you will integrate the y to the 3rd or the cube root of y, either way you want to do it, doesn't matter. So let's see, y equals 1, so the y's are 0 to 1, so same bounds. The only difference is it's going to be the cube root of y squared or y to the 2/3, however you want to do it, will be what you put in your integral. Does that make sense? Do I need to show anything?
Wait, why would it be? Why did the 2/3? Wouldn't it be the 1/3?
Well, you have to square it in the formula, pi r squared.
Oh, never mind. That makes sense.
But yes, your radius, your r would be y to the 1/3. And then you just have to square it, that's all. That's why it's 2/3. Ooh, number 9, they gave you a nice pretty picture. If we're revolving around the line y x equals 1. Oh, yeah, excuse me. If we're going around the line x equals 1, my integral needs to be in terms of y's. So all of them are in terms of y's, okay. All of them have a pi out front. All of them are from 0 to 2. That's pretty nice of them. So the question is, what is the function look like? So is it going to be a disk method or a washer method?
Disk.
Do we agree with Tanner?
Yes.
Okay, so if it's a disk method, can I eliminate any answer choices right now?
B and C maybe.
Okay, so Tanner says eliminate B and C.
Wait. I don't know what's going on C.
I think B. I don't know. That's
You
Yeah,
can
I don't know what's going on C.
definitely eliminate B because that is the washer method. That's 1r squared minus another r squared type idea. There's another one I can actually get rid of as well.
A, because A is the same thing.
A is not the same thing.
A doesn't have squares anywhere.
A didn't square anything because the y squared is actually coming from the function.
So you can
Um,
get rid of it.
so you can get rid of that. So A and B are out the window because they're both, A is just wrong. And B is using
Yeah.
the washer method. If that would be if I was rotating around the x-axis or the y-axis, sorry. So that's what B would be. So it's either C or D because both of those are squaring the whole thing. The question is, what is my radius? Well, if you solve the function given for x equals, you do get the y squared plus 1, which is why all of them have y squared plus 1. That's good. But it's it'll be minus 1. So it's always right curve minus left curve. If you're doing a vertical one like this. So the function will be C because the right curve is the y squared plus 1 and the left curve is the minus 1.
How do you get the -1?
If you draw a line from the curve to the vertical line,
Oh,
right minus left. Right is the y squared plus 1 minus the left, which is 1. That forms your r, so that whole thing becomes squared, as in C.
see, because it's around the line x equals 1, I would have not thought of that, I guess.
That's why I said anytime you do these pictures, the volume always draw the line from the top curve to the bottom curve, right curve to the left curve, wherever, to the what you're rotating around. So in this case, I would draw a line from my curve, the actual curve there, to the vertical line. And that's the only radius I would have. So that's right minus left.
Yeah, and you just, yeah, I gotcha.
Okay. Uh, so number 10. Okay, so they basically just a concept question of how you would find it, not actually finding it. So obviously all of them are going to be x1 to x2. So those are your bounds because it's x's. That gives you that, okay. Are there any answer choices that we know are bad right off the bat?
A and B.
Why A and B?
There's no pi.
Okay, so there's no pi. Um, any other bad answer choices that'll let us?
D.
Why is D a bad answer choice?
Because they separately squared the -2.
Okay, so what does that mean? Why is that bad?
Because that's not what we're doing.
What do you mean that's not what we're doing?
Like, that's not what you do.
It could be, very well.
Well, it's not the washer method.
Well, how do you know it's a washer method, not a disk method?
No, it's not the washer.
How do you know it's not the washer then?
Because it's touching the line it's revolving around. Like there's no space.
That's the important part. You're revolving around the line y equals 2. Had we been revolving around like the x-axis, then D would be correct. So that's where you got to be careful. Always pay attention to what you're revolving. So if they just change that last thing to say r is revolved about the horizontal line y equals 0, or if they said the x-axis, then D is correct. But in this case, since it's the line y equals 2, the whole region is flush up against it. That creates a washer method, or a disk method instead of a washer method. That's why C is correct. But you do have to be careful, because it could have been D. It just depended on what you're revolving around. Alright, number 11. We're revolving around the vertical line x equals 2, which means what? What does that tell us about our integral?
It's gonna be another disk.
Well, I don't know that yet. Just the fact that it's rotating around the vertical line. What does that tell me?
Oh, that you gotta have Y's.
So that lets me get rid of choice C. C is wrong automatically, because I do have to have Y's. And then as I'm looking at my other things, A and B are disks. D is a washer. So if it's a washer, the answer is D. I'm done. If it's a disk, the answer is A or B. So this does end up being, since we're, let's see, vertical line x equals 2. It's bounded by what we're rotating it around, so it's going to be a washer, or sorry, a disk. I'm crazy. So I can eliminate D. So C and D are out. It's either A and B, so it's down to my bounds, because if we look at those two functions, I don't have to solve for the function, because they've done that for me, basically. So I know it's either from 0 to 3 or 2 to 4. And I just need to know what my y bounds are. And we know it's bounded above by the horizontal line y equals 3, so the answer is B. So without even actually looking at any of the functions, I've figured out what the answer is. Does that make sense? Kind of the thought process I just went through?
Yep.
Now, clearly, you have no multiple choice this year, but those are things you should still think about as you do things and take tests and all that fun stuff. 12. Is 12 going to be a disk or a washer?
Washer.
That is definitely a clear washer problem, correct. So A and B are both out. What's the difference between... So we got some signage difference in C and D. So I'm just going to look at the first one, because as soon as I know if it's x minus 2 or x plus 2, I'm done answering the question, because that's a major difference between the two. So the first one being x plus or minus 2, that's going to be the line. So I'm looking at the line. We're rotating around the line y equals negative 2. So if I was to draw a line from the linear function down to my y equals negative 2, and I do top curve minus bottom curve, it'll be x minus negative 2, which gives me the plus 2. So D is the correct answer choice. Does that make sense?
Yep.
Okay. Let's see, 13. So we have two lines, vertical line x equals 4. Hey, Dad. What is the volume of the horizontal line y equals 2? Okay, so that's going to be a washer. My bounds are going to be from 0 to 4, because everything's in terms of x's. Actually, you know what the big R and little r. So you'd have to actually, I would probably suggest drawing a sketch of the graphs on this one, to be honest. Since they're linear, they're pretty easy. Top curve. So they both have the same y-intercept. So the top curve will be 2x plus 3. So it'll be 2 minus 2x plus 3? Or
No, it'd
no,
be
they'd be above
2x
it. My
plus
bad.
3 minus 2.
2, yeah. picturing the wrong graphs in my head. So it'd be 2x plus 3 minus 2 squared minus x plus 3 minus 2 squared. If that makes sense to everybody, hopefully it does. And if I need to write anything out, I can. But your tops are, both graphs are above the line y equals 2. And again, definitely with questions like this, draw a quick sketch of the graph. Will definitely help you with all of that. I would never do these problems if I was actually doing them on a test without drawing a sketch of them. Or if I have a graphing calculator, depending on the question. Do I need to do anything for that one, or is that understandable for everybody? Okay, take this out and says, oh, we're good. 14, which find gives the length of the curve. That's just 1 plus the derivative squared. So the derivative being 3e to the 3x. So it's 9e to the 6x. So d. That's just making sure you square the derivative. So that's following the arc length formula. And then which of the following gives the length of the curve? And again, same thing. So derivative formula.
You said it's the derivative squared, right?
Yes, ma'am. So that's the integral of square root of 1 plus. I usually just use functions because we mostly use functions. So that's just the derivative or integral of the square root of 1 plus like f prime of x all squared. Not all squared, just f prime of x squared. It's a pretty straightforward formula. Which, well, I don't know if it'll appear this year or not. We'll have to wait and see.
Okay.
Okay, any questions?
Nope.
And we shall do free response tomorrow, which I expect them to be a little bit more difficult than some of the previous FRQs, to be honest. Okay, then you guys have a
Alrighty.
good rest of your day, and I'll see you tomorrow.
Alright, you too.